Okay, last 5 of these. The table above gives selected limits of the functions f and g. What's the limit as x approaches 5, f of negative x plus 3g of x? So limits, when you have a plus here, we can separate that into the limit as x approaches 5, f of negative x plus, and the 3, that's just a constant, so that can go out here. X approaches 5. This is really a question about limit rules, I think. G of x. So as x approaches 5, well, this is really approaching negative 5, right? I mean, these values are going to get, as x approaches 5, these will get closer and closer to negative 5. So this is really about this limit. So as x approaches negative 5, that's getting closer and closer to 4. Right? As x approaches 5, negative x is getting closer and closer to negative 5. Plus 3 times the limit as x approaches 5 of g of x is 5. So that's 4 plus 15. That's, I don't know, that seems like an awfully easy one, like that. Well, 86 is A. All right, a tire that is leaking air has an initial air pressure of 30 pounds, so there's an initial value. Function t equals f of p models the amount of time in hours it takes the air pressure of the tire to reach p psi. What are the units for f prime of p? So the units for f of p, so this is time. So if we wanted to make a graph of this, it would be time, that's what comes out on this axis, and here f of p, this is p, so the units for this axis are psi, and the unit for this are hours. Right? If you were going to graph this, this is like, you know, if y equals f of x, then this is the vertical axis, this is the horizontal axis, time is being measured in hours, and p, which is taking the role of x here, is measured in psi. So the units for f prime of p, the slope of this, would be hours per psi, rise over run, which is d. So if you think, I mean, I don't know how accessible that problem is if you think about it in other ways, but if you think about it in terms of this graph and slope is just rise over run, that's pretty straightforward. For 88, the position of a particle moving in the xy plane is given by the parametric equation. So these are position functions, not velocities. What's the speed of the particle when t equals 2.3? So speed in 2 dimensions is the Pythagoreized speeds or velocities in each direction. So I need to find that, and I just need to know when time is 2.3. So I'm not even going to try to find those derivatives by hand. That seems like a bad idea. If you want to do that, the derivative of the cosine of 2 to the t is derivative of cosine whatever is negative sine of whatever times the derivative of what's inside. Derivative of 2 to the t is 2 to the t, but it wasn't an e, so you got to multiply by natural log 2. You really want to mess with that? No, I don't think so. So we're going to follow both of these, find both of these values just at 2.3. So I'm going to go to math. I'm going to do math 8. I want to find the derivative of this cosine 2 to the x at x equals 2.3. So that's my 3.3397, sorry. I'm going to square that. And then find y prime, it's the same thing, so instead of typing that whole thing in again, I'm going to bring up that entry, go back to here, and put in the sine function instead. and that's 0.719 squared. So I've got those values. So I'm going to do the square root. Can you see that screen okay? Sorry, that's kind of in the dark there. Of 3.337 squared plus 0.719 squared. And that's 3.416 or so. And this is close. Why am I off just a tiny bit there? Well, I rounded these to 3 decimal places, and I'm looking for an answer, so if you want to get that exactly, you could keep 4 decimal places here. And if it was a free response question, I would have done that for sure. So that's answer choice C for 88. 89, function f is defined in the closed interval 0 to 1, and it satisfies f of 0 equals f of 1/2 equals f of 1 on that interval. What does that mean? It means that at 0, 1/2, and 1, the function has the same value. I don't know what that value is, but it's the same for all of those points. Right? The y values are equal for all of those. On the open interval 0 to 1, it's continuous and strictly increasing. F is continuous and strictly increasing. Well, how the heck is that supposed to be true? So f of 0 equals f of 1/2 equals f of 1. So those all have the same value on the open interval from 0 to 1. On the open interval, f is continuous and strictly increasing. Which one of the following statements is true? Well, since this is the open interval, I think the only way that that could be true is if it's continuous and strictly increasing, then it can't be continuous at those endpoints, right? It's got to be doing something like this. If it's strictly increasing all the way through that interval, it can't go through those. It can't continuously, in a continuous kind of manner, go through those points. Well, that's the only way that could happen. So let's see what this says. F attains both a minimum value and a maximum value on that. I don't think that's true, because if it has these open circles here, then it never actually gets to a maximum value. It's just approaching a thing that it never gets to. So because that's an open interval there, it does not need to have a maximum and a minimum. That's true for continuous functions on closed intervals, right? If it's continuous all the way through the closed interval. F attains a minimum value, but not a maximum value. So that's not necessarily true either, right? The way I drew it here, it wouldn't have a minimum either. F attains a maximum value, but not a, no, that's same bogus stuff there. F attains neither a minimum value nor a maximum value. So that seems to be true if it does in fact have to look something like what I drew there. So I think D has to be true. And so does the College Board. And last one. So this power series converges conditionally at x equals 5. Which of the following statements about convergence of the series at x equals -4 is true? All right, well, let's see. If I plug 5 in here, okay, well, first of all, let's see what we can figure out about what we can say about this. This might seem very abstract now, so let's try to ground ourselves. Whatever this series is exactly, I know that it's centered at 1. Right? Because that's an x minus 1 there. And now I know it converges conditionally at x equals 5. Conditionally. And if you think about all the things that we've done with series, what happens in these intervals, the only places where we get this kind of conditional convergence, this is the kind of thing that happens at an endpoint. If it's converging conditionally at x equals 5, that's because maybe we plug that in and it's like the alternating harmonic series or something like that, right? So this I think they're trying to tell us here that this is an endpoint. So what can we say about the series at -4? Well, this series has a radius of convergence. If that's an endpoint, the radius of convergence is 4. So if I go 4 in this direction, I mean to -3, right? So it looks like -4 is outside the interval of convergence. So I think that we can say that the series diverges at x equals -4. And that's the correct answer, because it's outside of that interval of convergence. So that's a little bit tricky there, I think, to realize that this converging conditionally at x equals 5 is telling us that that's an endpoint, and then that is the center of the interval. Tricky. All right, there we go.